Hey, today we're going to be going over how to create this audio reactive shader using Three.js and Shader Park. All right, let's dive into it. So for starters, for brief explanation of Shader Park, it's a creative coding library for making interactive and procedural 2D and 3D shaders. So this is a shader right here, it's interactive, and same with the background, it'll animate when you scroll. And these are all things that you can normally create using GLSL, but it takes a lot of overhead to do that. And so Shader Park tries to simplify that process by making a library that's written in a similar style to a creative coding library called P5.js. One thing I want to point you to as well is our community page. So if you have any questions, feel free to hop onto our Discord and ask questions there. And we also have a number of different plugins. So we have plugins for Touch Designer, Three.js, Glitch, and Hickenunk. So another piece here is that you can see all of our different starter templates by going here. And these are examples of how to use them in your production website. If you click on the Glitch logo, these are similarly a number of examples that are production ready, but will run in the browser without needing any tooling. And if you search for 3, you'll find a number of different references here. So for example, this one will show how to render Shader Park on some text. This one down here will show how to apply it to custom geometry. So here's the text example. We can look around and get this kind of cool effect. Similarly, here's how we can apply it to custom geometry. So this is a shader applied to a torus knot, and it'll create this cool glitchy effect. If you haven't had a chance to watch the beginner series on Shader Park, I'd highly recommend you checking out those videos first. It'll give you a background on how to use some of the Shader Park library, and then we'll build off of some of those concepts here. But I'm still going to go in and show you how to create this shader from scratch. So if you want to follow it along here, feel free to do that, but definitely recommend checking those out first. All right, so for this next section, I'm going to go over 2 templates, and I'm going to put a link to both of these in the description. So notice this is the Audio Reactive Three.js Shader Park template, and this one's ready to go. This is like the fully built example that you can play around with. And one thing that's really exciting is that you can actually take any code from Shader Park and you can swap it out here. So I'm going to start by just going over to Shader Park. I went over to my profile and I'm going to snag like this shader, for example. It's running a little slow because I'm recording a video on my screen at the same time, but I can go ahead and copy the code for this shader. And one thing that I like to do is if I'm animating this sculpture with time, it's really easy to swap that out for interactivity. So I'll copy this and we can go over to the spcode.js file. And now the one thing that you want to do is keep this first and second line. So this is our audio input, and then this is our pointer down. So by default, we have the mouse input in Shader Park, but we don't have the click event. So you can see here, like when I click, it'll transition between this other shape. So let's keep those 2 lines, and then I'm just going to paste the rest of the shader code below. And then I'm going to go ahead and reformat this. If nothing shows up after you paste your shader in, one thing to double check is if there's any other inputs. So you'll need to make sure that those are defined in your script.js, and we'll go into how to add those in later on. Now, the other thing here is that I'm using time for my animation. All I need to do is go in and instead of using time, I'm going to replace it with audio. Okay. Then the last thing here is that maybe I want to bring back that click animation. So here I was mixing between a sphere and the shape that I created. So you can see that here I was doing 0 is the original shape, and at 1 it's a sphere. So maybe instead I'll use this pointer down so that when we click, it'll animate. So I can do that. Now it'll transition anytime that I'm clicking. And since we swapped out our time variable with audio, now I can hit play. can make it interactive. So for today, we're going to be building off of the starter template audio reactive Three.js Shader Park file. And we're going to go through and add in the audio reactivity from scratch. And we're also going to add the Shader Park functionality. I have most of it set up, but I just wanted to show the core differences between using a normal mesh and material in Three.js and how we can do that with Shader Park. So let's go ahead and dive into it. The first thing that you're going to want to do is navigate over to this starter template in the description, and then you're going to want to go in, make an account on Glitch, and hit Remix. One thing to note is that Glitch is just hosting our website. We also have the ability to download this and host it with whatever service that you'd like. And you can easily incorporate the same functionality into your own website as well. All right, so now that we have a remix of it, you can go into the settings and edit the project details, and you can give it your own name. All right, so let's go ahead and go over some of the core details here in the project. You'll notice in the HTML, basically we're importing Three, we're calling our script here, and we have a container that has a button. I'm actually hiding it by default. This is the button that pops up to play the audio. And then in script, we are creating a Three.js scene, adding a camera, a renderer, creating a clock element so that we can keep track of time. Here we're basically we're hiding the button that shows that the audio is loading. This holds our state that we're going to use shortly. It's just a dictionary that can keep track of like the mouse position and time, for example. We're creating a sphere geometry, the material and mesh, and then we're adding that to our scene. This handles the pointer events so that if you're on mobile or if you're on desktop, those mouse events will be added in. And then these are the controls so that we can click and drag and pan the camera around. And then lastly, we have our resize so that if we scale our window size, the canvas will grow and shrink accordingly. And then we have our render loop. So this is called 60 times a second, and this will update our mouse positions and things like that, and also render the scene with the camera. Let's go ahead and incorporate our Shader Park functionality. So notice that we're creating a sphere geometry here, creating a material, and then generating a mesh from that geometry material, which we're then adding to our scene. So this is the main area that we're going to customize. So we're actually going to have Shader Park handle a good chunk of this. Let's uncomment this, and no need for our mesh or our material anymore. Notice that we're using this function create sculpture with geometry. So that's actually imported from Shader Park core at the top. And what you can do is you can provide it a geometry, you can provide it your Shader Park code, and then it will generate GLSL for you behind the scenes, create a shader, and it will attach that shader material to the geometry and then give you a mesh back, which you can add to the scene. So notice that we are actually getting this 3D box here. Let's take a peek at our Shader Park code over here in this file. We're actually just creating a box, and you can see if we go back to our script that we are just importing that here. Now we could just write our Shader Park code directly in here as a string, but let's go ahead and go back just because it's helpful to have it in a separate file. Now, where did that sphere go, right? Because we're passing in this geometry of a sphere, but we're seeing this cube, this 3D cube. So let's go ahead and take this and scale it up much larger. And now you can see the bounds of the sphere. But then if I click and drag, you can see the corner of this cube if I get the camera angle just right. So the thing that's really interesting is that we're actually generating a 3D shader. So we're kind of simulating a 3D environment in the material of this sphere. So you can apply it to any 3D model that you want. One thing you could do as well is you could import an OBJ file or a GLTF or GLB, and then you could apply a custom shader to it using Shader Park. So I'm gonna go ahead and scale this back down a little bit. Next, what I wanna go over is this extra little section here. So notice that we're passing in time and we're also passing in the mouse parameters. These are kind of hidden when you're working with Shader Park in the editor online, but these are actually the ways that we get inputs into the shader. So these are normally referred to as uniforms, but in Shader Park, you'll see that we create custom inputs by creating something like a input. Okay, so we've made this size input, but let's go ahead and use this to actually control the size of our box. And notice nothing happens, it kind of just disappears. So what we need to do is go in and actually make a uniform for it, or an input. Here, we're creating a time uniform. So now let's make one called size, and we can give it a starting size. So if we set it to 0.5, now we can have that here. But wouldn't it be great in the rest of our JavaScript application to be able to update it on the fly, or potentially in our render loop? What we can do to make this process easier is store it in something like a dictionary to be able to reuse it. So let's add something in called size. We'll set it to 0.5 at first, and then here we're calling state.size. Make sure to put a comma, and now it stays there. One thing that's common is to update your uniforms every frame. So for example, we want our time to increment every single frame so we get a new value. And what we did to try and simplify that process is that this little function right here actually gets called every single frame. What this allows us to do is to update any value in our dictionary for state, and it will automatically pass that update to the uniform. So notice, for example, like how do we get time to update? Well, what you can see here is if we search for time, well, we're updating the state's time with the clock delta in the render loop. And then automatically that gets assigned to the uniform time. One thing you might be wondering is where is the call for an input for time or for the mouse? Well, we actually do that behind the scenes for you. We figured that it would be helpful to just automatically have time as an input and also the mouse input. So, behind the scenes, we have something like this for time, but that's there for you already. But one thing that we don't have are click events. So let's go ahead and re-enable that. I actually have it commented out right now. So if we uncomment this pointer down, and then we add in an input, now we can use click events. So let's try that out. Instead of size, what if we used pointer down? Now when I click, it'll animate. And one thing you might be wondering as well is like, well, how are you getting that smooth animation when you're clicking? If you scroll down here, you'll notice that I'm actually interpolating. So this kind of adds some easing to it. So instead of setting it directly to 1 or 0, every frame we're adding a little bit of easing. So it slowly increases to 1. And then when you lift your mouse up, it will slowly decrease back down to 0. And we're doing something similar here with the mouse positions. Alrighty, so the last thing that we need to do for setup is to add in our audio analysis. Let's head over to Three.js. And if we go into the documentation section and look for audio analyzer, we get a really helpful resource. So notice that we create a listener that gets added to our camera. Then you get a specific sound that we'll use later on to do our analysis with. And this part here, this is where we load the actual audio. So you make an audio loader, pass in the URL for the sound, and then you get back the buffer. And so this is where you'll do things like set the volume, tell it to actually start playing, and we'll link up this part to the button that we have on the website. Because if you're on mobile, you can't just automatically start playing. You have to link it to a user-generated event. This function will run asynchronously, and here we'll create our analyzer and we'll say how many bins we want. This will basically break our sound into discrete bins. So the analyzer will run something called a fast Fourier transform on the audio. And what this does is it organizes all the frequencies from low to high. And here we get 32 discrete samples. So 32 unique bins, and it'll tell us 0 to 255 values for the intensity. In our case, what we're going to do is use the analyzer, and instead of getting the average frequency, we're actually going to get back the frequency data and get a specific piece of data out of it. So we're going to just look at like some of the low notes, so that way we can do kick detection. For a visual reference, I'm previewing the audio in Touch Designer. For example, this is what our audio waveform normally looks like, but what the analyzer will do is it will break it into discrete bins. So we can see here now all of the notes every frame that we get are organized from low to high. And you can see like, oh, okay, there's a lot more bass here into our mids and our highs. And what we're able to do is we can sample from a specific bin and then get that value back and use it however we'd like for our visuals. So let's go ahead and bring that into our project. Let's go ahead and copy these lines of code, go back over to our project, and then after our button display, let's go ahead and paste the code in here. Now, one thing to note is that I've already imported the individual components for Three.js. This kind of keeps the library more lightweight instead of bringing everything in and just defining three globally. So we can remove this 3 dot beforehand, and we'll just load the audio analyzer. And then what we'll do is we will tack that into the import. Same thing here for the audio loader, and the audio analyzer. I'm going to just change the size of the box here so that I know that it's still rendering things correctly, just for peace of mind. And next, let's go ahead and add in our audio. So if you want to bring audio into Glitch, what you can do is just take any audio file and you can drag and drop it into this section. And then once it's there, you can click on it and it will give you the URL to that file. So we can go ahead and copy this. And if we go back, notice here, we'll put in our URL. The next thing that we'll want to do is set up our button. So notice here that we're setting the display to none. We'll want to set it up so that if we click on it, it will then play our sound. Let's do this. Once we are in this callback function, so notice this little function right here, this is triggered once it's done downloading the audio. So here, now we can set display is equal to block. There we go. So now that appears after the audio is loaded, but it's not still loading the audio. So let's go ahead and change the text. Very cool. All right, so once it's finished loading, we'll set the inner HTMLs to play audio so that we can click it. But the other thing that we want to do is we also want to add an event listener so that when you do click, it will play. Let's go ahead and add that event listener here. And then once we've clicked on the button, we can play our sound. And lastly, let's hide our button so that way we can see our visuals in full screen. We'll set it to display none to hide it, and that should do the trick. Hey, Torin from the future here, quick little correction. Instead of setting the element to display block after it's loaded, we actually just want to remove this little display none beforehand. You can delete this line and you can remove the display block. We want our loading audio button to show up and be visible all the time. And then all we want is the text to actually just change to play audio once it's finished loading. Then once you hit play, the button will disappear again so you can be immersed in the visuals. All right, last steps for this. We just need to actually perform our audio analysis. So notice here we're creating our analyzer, and let's go ahead and in our render loop, we can call analyzer.getAverageFrequency. And let's go ahead and store that. So let's go ahead and log that. And if we play our audio and then look at the logs, notice that we're getting an array and we're getting values that are between 0 to 255. So what we can do here is let's go ahead and take our audio analyzer, and let's just get like bin 2, for example. It's going to give us a lot of the low notes, and we're going to take this value and divide it by 255. So now we're getting a single value out of this. And what does that look like? Okay, awesome. We're getting values from 0 to 1 now, getting around like 0.6. And something that I've found is that it's helpful to kind of scale these values down a little bit. So let's go ahead and let's multiply it by like 0.8. And we can also raise this to a power. So I've found that like around 8 works best for my song. And what this does is it takes a larger change in our audio analysis in order for this value to be closer to 1. So for example, when a kick drum happens. The other thing though is that this gives us a single discrete value. What I like to do for my animations in Shader Park is to take any animation where I'm normally using time and I swap it out to use this audio analysis. So we actually need a value that's continuously incrementing. So let's go ahead and add a value into our state so that we can hang on to this. So I'll uncomment our current audio, and let's go ahead and set state's current audio, and we'll plus equal it to this analysis so that every frame it's adding to it. And one thing that I like to do is like add just a little bit of time into this value. So we'll add state.time, but we'll like scale it down by 0.5. And that way, if there's no audio playing, this animation will still take place. The last thing I like to do here is add a little bit of easing to the audio. So the same way that we have some easing applied to the mouse click, we can do that with the audio, and it'll smooth out some of the jitteriness of it. So that's why I have this other parameter here for audio. And we can basically do the same calculation that we're doing here for the pointer down, where we're taking the current pointer down and we're taking 10% of that every frame and 90% of the previous state. So let's try something like that out, where we'll set states audio to, let's get maybe like 0.2 of our current audio plus, and so like these two numbers need to add up to 1. So 0.8 times our states audio. And what this does is like we're getting 80% of our previous frames audio and 20% of our current audio. So if you want to have more easing, you'd make this number larger and this number smaller. Now that we're storing our audio into our state, we need to also make sure that our shader has a uniform called audio. So we can uncomment this and also make sure that we've created a key called audio in our state. And once that's there, we can, in our SP code, also have an audio input and use that for any animation that we want in our Shader Park code. A couple of things we'll want to fix up before we create our shader from scratch. We don't actually need this size input anymore, and you'll want to go in and remove this size uniform from Create Sculpture with Geometry. And then the last thing, I actually had this little part wrong. Instead of using our current states time, because that's going to be a very large value, we just want a little bit of our current clock. So swap this out, otherwise your shader is going to be moving quite fast when we use our actual audio. But now we're ready to create this shader from scratch, and once that's generated, we can paste the code in here and it should be ready. Go ahead and navigate to shaderpark.com/new, and if you haven't made an account or logged in, go ahead and do so you can save. And let's dive into it. We're going to start by making a box frame of size 0.5, 0.1. So this last parameter here is going to change the thickness of it. And here, right now, the vec3, we're basically passing in the same value for the x, y, and z. So we could fill in, we can change the size of it, but it's helpful here just to have a default size of 0.5. And when we finish the example, we're actually going to scale it up to 2, but to illustrate some of the other operations in a second, it's helpful to have it small. So the next thing we want to do is be able to blend between these two pieces of geometry. So we can mix geo, and if we do it by a small amount, you can see we can start to blend between these two. And you can also animate that. So we can do the end sign of time, and that will just continue to animate. And if you want to have a slider to be able to control it manually, for example, in our demo, we had it set up so that if you click, it will do this transition. So let's give it a name. We'll call it pointer down, and we'll make an input. Now, inputs are actually a uniform under the hood. If you come from a shader programming background, these are the inputs that you can get into a shader from an external source. So we can give it whatever name we want, and here we'll go ahead and replace that. And when you're working in the Shader Park editor, you get a nice little slider that you can use. But if you're adding this into your own website, you'll be providing these values. And we can make another one as well. So we could make another input. Let's call it sphere size. And we'll pass that in. So now it starts at 0. Oh, we'll set that back to 0 as well. And now we can change the size of the sphere using an input. One thing to note as well is when you're working in the Shader Park editor, you can also specify a default value. So now this pointer down will default to 0.2, and then you can also give it a minimum and maximum range. So it could be from 0 to 4, and now the slider will update. It's interesting, actually, you can push the bounds of the mix function here and kind of push it beyond what the geometry, how the geometry is defined, and you'll get some pretty interesting artifacts out of that. But let's go ahead and go back. So we can just keep this at, let's keep it at 0 for now. We don't need our sphere size. We'll keep that at 0.5. Let's go ahead and give this some color. We're going to give it the color of the normal, and we can scale it down a fair amount, so like times 0.1. And one thing I like to do is add a little bit of a base color. So we can give it a base color of a vector 3. So 0 in the red, 0 in the green, and then let's give it all blue. That gives it some nice coloring. Next up, we're going to add some noise. So the first thing we need to do is get our coordinate space. And let's create our noise. All right. And we can add this into our sphere. And let's scale it down. So times like let's say 0.5. So right now it's not animating at all. We can add in time. Maybe let's slow it down a little bit. And you can also animate the noise in a specific direction. So if we add in a vector 3, right now, we could set it so that it's 0 in the X, 0 in the Y, and only in the Z. Or here's what it looks like if we add it in only the Y direction. Let's go ahead and go back. So it's just animating in the Z. The other thing we can do as well is we can scale up and down the noise function. So right now we're really zoomed in on it. And if we multiply this by a larger number, we'll kind of zoom out on the noise function to get smaller and smaller detail. Notice that you actually get a fair amount of artifacting. So let's go ahead and keep this pretty low right now. And there's another way that we can actually sample our noise function, and it's by getting our ray direction. Let's actually just go ahead and duplicate this, and we'll call this noise 1. And instead of sampling the space, we'll sample the ray direction. This is the direction that the camera is pointed towards the object. And here, instead of sampling by n, let's do n1. And we can scale this up by 20. And let's set this back to n. Okay, let's go ahead and scale this. maybe multiply it by 4. And one thing that is really cool about this is that we can actually add in a nested noise function. So we can sample by noise 1, and we start to get these really cool patterns that emerge. Okay, so we're super close here. A couple of things that I would encourage you to play around with are like the size of these. So we could, increase the scale here. Same with this point here. The other thing I want to do is add in a little bit of material properties. So by default, we're using physically based materials. And what we can do here is we can add in the metal. And if we add in a small amount, it's a little hard to see. But if I change it to like 0.9 and then 0, you can kind of start to see this as I toggle it on and off. You can see the difference in the lighting. So we can actually use the noise function for this. So I'll add in the noise, but we only want values that are from 0 to 1, so we want to normalize it. So we'll multiply it by 0.5 and we'll add 0.5. And that gives us a better range. And we can also add that into the shine. We'll do the same thing. And that gives us some nice lighting in here. If I toggle it on and off, you can see that we start to get some highlights in here that make it look a little bit more 3D. So 2 last steps. We can play around with the underlying ray marching engine. And what we can do is turn off the number of iterations that are taking place, and we can limit it. And you start to get this really interesting 2.5D effect. So we can change that by calling set max iterations. And by default, I think it's around 300. But as we start to bring it down to something like 10, you can see some really interesting artifacting. But if you put it at like 5, we get this really cool kind of like refraction watercolor type effect. The next thing we're going to do is we're going to displace our object so that it moves with the mouse. So let's do that. We can displace by mouse.x. Let's maybe scale it up a little bit, and mouse.y times 2, and nothing in the z. So we can get some nice motion here. And then let's just scale up our box frame so that it's much larger. So we'll bring that back up to 2. And now when we have the pointer down, you can see we're inside this large box frame. So what we're going to do next is bring this into our template. And then we'll add an audio reactivity. So actually, instead of using time, what we'll do is we need another input for it. We're going to make another one called audio. It's going to be equal to an input. And then what we'll do here is anywhere that we've used time, we're going to replace it with audio. So then we'll do our audio analysis in Three.js, and then this value will control externally. All right, let's get this linked up. So now we can paste in our shader. And there it is. Okay, awesome. Now it looks a little bit big for starters. So what we can do, there's a little hidden uniform that we can take advantage of. And this is why we have all our coordinates in Shader Park scaled from 0 to 1. And it's because we can pass in underscore scale, and we can tone it down a little bit. So now it's zoomed out quite a bit. And this allows us to basically scale up and down our coordinate space uniformly. So the last thing we want to do is basically just zoom our camera in by default so it's much closer. That starting point is defined up here. So the camera's Z position is scooted back quite a bit to 5.5. So let's set it to like 1.2. And now we're all zoomed in and it should work. All right, so you can go ahead and if you hit the preview button and open it in a new window, you can have it as a full screen experience. All right, thank you so much for following along. I'm really, really excited to see what you'll create using this tutorial. And if you enjoyed this, consider hitting the like and subscribe button. I also have a Patreon, so if you want to support the channel, that's a great space to do that. Thanks again. See you in the next one.